Right, hello and welcome to another Dauntless Development video. Today we are doing another C# beginner tutorial. We're going to be covering loops. Now we covered a while loop a bit last time, but we're going to be covering them all today. And we'll also, because of the way one of the loops works, we'll also be introducing something called a list, but we won't be going too in depth with that, at least for now. That's something we will cover more in depth at a later date. So what we have, so what we're going to start off with is what's called a for loop. So a for loop is structured like this. So you start off with the word for, you open some normal brackets, some parentheses, and you start off by setting a thing to do before the loop starts. So generally what you'll do is you'll declare a variable. So I'll say int I equals 0. So this is what we're doing. We're starting it off by declaring a variable and assigning its value. Then we put a semicolon, and this argument that sits in the middle is the condition which is has to be true in order for the loop to continue. So we'll say I is less than 10, which means as long as I is less than 10, it will keep going through this loop. And this last thing is what happens after each stage. So it's what happens every time it goes through the loop. It's an action that kind of happens along with the code. And what we do here is we say I++. Now these aren't, you don't necessarily have to do this. That's why I explained it in the way I did. So this is just something that happens before. This is something this is the condition, which means this must be satisfied in order to keep looping. And this happens every single loop. Generally, you will use this as basically setting up a counter. That is the most common way you'll see this. You'll set up a counter, so you'll use this kind of loop to count through to do something so many times. However, you can do it other ways. You could start with a higher value and use I minus and do it whilst it's greater than a certain number, like greater than 0. You could use it as a countdown, but this is a very typical way of seeing it. So what we're going to do is we're going to say console dot write line, and we'll just say I right here. So all this is going to do is it's going to initialize an integer called I to 0. It's going to loop whilst I is less than 10, and then it's going to increment I by 1 every single loop. So when we run this, we'll see that here. So it starts off 0 and it counts up all the way to 9. So this is actually, it does it 10 times because you include 0. Now, the reason it stops is because once I becomes 10, it's no longer less than 10, therefore it won't execute the code. Okay? So this, by the way, this console read key, we've done it before, we've had it here. This is just a way of stopping the program from closing afterwards, because if it's not waiting for any kind of input, it often closes instantly. So console.readKey just means that it'll wait until you press something. Okay, so we're just going to comment this out using a little keybind. So if you highlight some code and you say Control K and then Control C, it'll automatically comment the whole thing out. You can reverse that by doing Control K, Control U, but we're going to put it commented because we don't want this code to execute anymore. So for the next bit, we're going to have to declare the variable here. So we're going to say int I equals 0. And then what we're going to do is we're going to make a while loop. So this is while, and then we'll put in here I is less than 10. And then we can say I++. And then we can do some code in here. So we'll probably put that same console.writeLine. Now, this is exactly the same. This is functionally identical to this loop. So we're just setting a variable here instead of in this bit. We're then putting the condition here instead of in the middle. And then this little I++ is what happens at the end of every loop. So what we can do is we can run it, and we'll see exactly the same thing happen. Now, you might be wondering why there are different types of loop if they do basically the same thing. Now, while it is true, you can pretty much use any loop to do anything, like any other loop's job. they are better suited to certain tasks. Like the for loop is better suited to counting up through a series of numbers or doing something a set amount of times, whereas a while loop is better for just doing something while something is true. So you could have for a while loop, you don't actually need to set a precondition kind of thing here. You don't need to set something to happen every time. You can just have it while something is the case. So that could be in a game. You might have like whilst the player's alive, and then do all the code whilst they're alive, and then you don't need to like count how many seconds they're alive or anything like that. You can just, as soon as alive is set to false, it'll stop running the code. So although they can do the same things, this is definitely the best task. This kind of counting through numbers is definitely best suited to this for loop. Now we're going to just comment this out again, but we're going to keep the integer because we're going to use that in the next bit. And we're going to do very similar to the while loop, kind of the while loop's cousin, called the do while loop. So the do while loop is very similar. So you open up some brackets, some curly braces, just the same. And then at the end you say while, open up some brackets, and we'll put a condition. So I'll just say whilst I is less than 10 again. And then semicolon at the end. So what this does is this does the code inside here every time, no matter what. So it'll always do it. It'll always do it once, and then it will check this condition. Now, so this will perform functionally the same as the previous one. However, what is beneficial about this is it will always run the code once. So say if you, for example, if it was instantly turned off, say, like if this condition instantly became false after the first loop, or maybe it starts off false, it's something that it'll always do it once at least. That's the reason for the do while loop. So it's very similar to the while loop. I can't say I've often used a do while loop. It's nowhere near as useful as the while and the for loop. They're probably the most common loops you'll use, because a while loop tends to be what you wrap around your whole program, and a for loop is just very useful for counting through things. So I'm just going to comment that out using Control K and then Control C. One thing I just want to mention about that keybind is I'm not pressing Control K and C at the same time. It's Control K and then Control C. It's two separate presses. Just in case you're curious. So we got that, and I'm just going to quickly comment this out as well. So that's all the loops there, but it's not quite all of them. There's still one more loop remaining, but this loop is specifically used for looping through a collection, which could be an array or any form of collection. But what we're going to do is we're going to use a list, because that is a very common and very flexible collection in C#. So we're going to create a list. So a list is created by using the keyword list. Then you use these little angled brackets here. So it's like a greater than and less than symbol. And you put a type of data in here. So we're going to just hold a list of ints. And we're going to call the list, let's just say numbers. And then we can say equals new list of ints. So whenever you're declaring a list, you need to initialize it. So that's what I'm doing here. This is something that we'll cover at a later date. This is something I'm just briefly using because I have to put it in order to use a for loop. A for each loop. But just for future knowledge, that's kind of how you set up a list. So what we're going to do is we're actually going to recycle this for loop just to populate the list, that is. So all we're going to do is we're going to just say numbers.add, and then we'll say I. So this is kind of a way you could use them in tandem. But all we're doing here is, instead of writing it out, we're just adding that number to the list. So we're going to have a big list, and you can imagine it kind of like a shopping list or any form of list. It's just going to put a comma, put a new one afterwards, or a new bullet point, or however you write your lists. So it'll just add a new number to the list. What we can do is we can make a for each loop. So a for each loop, we can just say for each. Now we know we're looping through a collection of ints, so we can say int, and we'll just say for each int I, in numbers. In fact, we'll say int n, because it's kind of common practice to use kind of so for every number in numbers kind of thing, you'd write it like that. So you could write the word number as well. That's also very common. None of these things like that are rules, but they're just common practice, and it's kind of it's good practice to use the most kind of commonly used things, so that your code is very readable and it's very understandable to other people who are programming, which is not as important if you're by yourself, but if you're working in a team, you want your code to be as clear as possible for other people. Right, so what we can do is we can say for each n, so what we can say is, so what this is doing is this is going to go through the loop, very similar to this. It's just going to go through until it reaches the end of the list. So we're going to just say n console.writeLine console.writeLine, and then we're going to just say n. So now when we run this, it does exactly the same thing. So this for each is specifically used for looping through a collection. And even more specifically, it's used for looping through a collection when you don't need to know the index. So you can see here that we could also use a for loop. So we could use another for loop instead. So we could say for int I equals 0. Oops. Just doesn't really matter about having spaces, but it just looks neater. So int I is less than 10 I plus, and then we could say console.writeLine, and then we say numbers, and then we put square brackets, and we just say I. So this is how you access a collection. Yeah, again, I'll cover these kind of things in more depth. But what we're effectively doing is we're just counting through the list. So if we needed to know information about like which item we are accessing, like which number it is in the list, we'd use a for loop. But if you don't need to know specifically, like you're just doing something to everything in a list, under those circumstances, you'd use a for each loop. So yeah, this will, as I said, this will do the same thing. I'll just comment that bit out so you don't see it twice. But yeah, it does the same thing. One thing to note, I'm just going to delete this for now, is, I'll just uncomment that. One thing to note is what you can do with a for each loop, which you can't often do with other things, is you can use a variable called var. And what that does, as I covered briefly, is this will automatically adapt to whatever type of information it is it's taking. So whatever's trying to be stored in there, the compiler will try to look and say, okay, they're storing an int, because this is a collection of ints. It knows that, okay, this is going to be an int. So this is just the same as if you wrote int, but if you wanted to just kind of have a consistent structure for everything, you could just use var. And it's just quick, because then you don't need to double check what you're typing. Whenever you're doing a for each, you can just type var, and that does exactly the same thing. So yeah, that's just loops, and just that's all there is really to them. They're not particularly complicated, yet they are very powerful and part of the backbone. I'd say kind of the two things you can't live without with programming is definitely loops and if statements. With loops and if statements, you can basically do anything. So yeah, that's all for today. So thanks for watching, and I'll see you next time.